Greetings and welcome, friends. We were talking about like equations of perpendicular lines and their properties, etc., and finding distances between a point and a line. And so here we go. Let's just jump right in. It says write an equation of the line passing through the point P that is perpendicular to the given line. Oh, it said to graph them. We'll see if I actually bother to do that. We'll find out. Who knows? It's a mystery. So here's the equation of their line. The first thing I'm going to do is write that in slope-intercept form. Also, internet friends, I'm moving a little faster than normal because my estudiantes have a test today.
Help us.
Help us. Yes, yeah. Yes. Save us, internet friends. Let's see, divide everybody. These are dividing, yeah? Oh, is this like one fraction bar too short for your like? Yeah, so that's positive 3/5 x minus, I guess I could call that 1 1/5 or 6/5 or 1.2, but I'm a fan of the fractions. But in this case, at least it's an exact decimal. So the reason I rewrite their equation in slope-intercept form is that I could then take their slope, which is 3/5, and because our line is perpendicular, our slope is going to be the opposite reciprocal, which is 5/3 of the negative variety. And so there's one of our facts about our line. Are you okay? How are you feeling? What's up? Or is your mind blown? Okay, mind blown. And then I think you guys in general preferred the slope-intercept form to plug in these two as points for x and y, our slope for m, and then solve for the corresponding b that will make our equation true. So negative 5/3. Oh, that's going to be fractionic. Fractionorific. There we go. All right, at least I don't have to do much work with the fraction. So it's going to be positive 40/3 plus b. Subtract that from both sides. I end up getting b equals 40/3. And since I don't have to do anything with this, I just have to write the equation. I won't even bother. Oh, with the save, that's right. Wow, man, that's what I get for like skipping my one step of subtracting that from both sides. That is correct. Thank you for the save. Negative 40/3. Y equals, we write our own equation with the m and the b. We don't plug in our x1, y1 because I want it to represent all combinations of x and y that make the equation true, of which there will be infinitely many. And those points, when placed together on a grid, would represent slope, the line, right? And yeah, so all those points would be the equation of the line. What is this? Oh, I wrote it in slope-intercept form. I plugged in my m and my b, so like so. And if I graph these would be perpendicular to each other, but question? The y-intercept is where the line crosses the y-axis. In slope-intercept form, it's convenient to graph them in that form. Point slope form, you could pick any point on the line and represent it in your equation. But the reason that we picked this specifically was because we wanted the equation that was perpendicular and passing through the given point, of which this is the only line that makes that true, where there are infinitely many lines that would have this slope being perpendicular to the given one. Tell you what, I'll show you a quick graph here. Why not, shall we? Let's see. Yes. Sometimes I like to just pronounce it giraffe. You know, that's how we talk about graphs on the street. So let's see. Negative 8, 0. I could plot that point. So negative 8, 0 is there. Let's graph, what was it, 3x minus 5y equals 6. Nice thing about Desmos is that you can write your equation in standard form. And so I'm expecting my perpendicular line to look, you know, like this or something. And let's see what happens. So we had our equation was y equals negative 5/3 x. That's perpendicular. And then minus, according to Emmett, 40 thirds. And bam, direct hit. Right, notice our line passes through that point. Yeah. So there you go. Actually, check this out. Can I do this? B. And then I think I can add a slider for B. No. Oh, that's what I would do. Plus B. Add slider. There we go. And notice, look at this. I can actually like slide that around. I just write an equation that has a variable in it, and then there's a button that shows up that says add slider. Thought I wanted, there we go. Yeah, so notice these are perpendicular lines to that, but there's only one that would pass through the point exactly, and that happens to be at negative 40 thirds, which I'm guessing is like, I don't know, that's probably like negative 13.3 repeating or something. Right? So, okay. I tried to pick a tougher, the trickiest problem from the batch, I think. That's 18. Wait a minute. Let me check. All right, I'll take a moment here. All right, 18. Well, I already did one of that. I did 20, which I thought was the trickier one. For 18, your slope is 0. Y equals 0x minus 3. It's a horizontal line. A perpendicular line would then be the one that happens to be vertical. And so it would be x equals 4. All right, I guess actually I just explained that long enough that, and this one's a speedy one. I'll do 18. I'll do 18. Watch this. I just fit 18. Oh dear, what happened? Oh my goodness, the humanity. Ah, that was terrifying, friends. So the slope of this line, I could rewrite that as y equals 0x minus 3. Right, so their slope is 0. Our slope is undefined. All right, which means it's a vertical line. Okay, and vertical lines are going to be of the form x equals some number. All right, where that number is going to be the x-coordinate of any point on that line. So the vertical line to this one that passes through that point would just be x equals 4. So that is a good question. Thank you for asking it. And 22. It says find the distance from point A to the given line. So the first thing we had to do was find a perpendicular line. That was what I think I called step 1 back then. It's been like a whole weekend since we did this. The slope of this line, the coefficient of the x is 1, so m1 is equal to 1. The opposite reciprocal of that happens to be negative 1, because we're looking for perpendicular. And now I'll just plug this in. It's pretty much identical to the problem that I did just a moment ago for the step 1 part. So I'm going to have negative 3 equals negative 1 parentheses negative 9 plus b. We'll solve for b. Negative 3 equals 9 plus b. Subtract 9. I'm going to write this out this time because my shortcuts made me wrong. And so I'm going to get b equals negative 12. All right, so the equation of the perpendicular line is y equals negative x minus 12. And I could imagine the system of equations being y equals negative x minus 12 and y equals x minus 6, which step 2, if I'm trying to find the distance from a point to a line, was to find the intersection between the perpendicular line, this one, and the given line, that one. So I'm going to try to find the intersection. The way you can do that is using substitution or using elimination method, which actually adding those two equations together for elimination method is great. But I'm just going to stick to substitution because it's probably the one with the easiest to follow steps, and it might be a while since you've done elimination, and I don't feel like taking the time to re-explain an entire concept like that. So I substitute. If y is equal to this, then I could plug that in for the other equations y. Notice the benefit here is it gives me one equation with one variable. And then I could solve for that variable. And that value of x will be the x coordinate of the intersection between both lines is what that will represent. Let's see. Wow, guys, I remember how to do math. This is great. And then divide. Oh man, I'm running out of space here. I get x equals -3. So that is the x coordinate. To find the corresponding y coordinate, I would then take this and plug it into literally either of those equations. Either of them for its x. Oh dear. Let's all right, stop. My computer's doing like this weird alt-tab thing, even though I'm not telling it to. So let's see. So I'll have, continuing the work over here, y equals, instead of x, I've got -3. Substituted, -6. I get y equals -9. And so the intersection of these two lines is -3, -9. And now, the final part, they asked us to find the distance, right? Distance from point A to the given line. We measure that distance perpendicular to the line, which is why I found the perpendicular equation, and then their intersection. And I'm going to do the distance formula using the point they gave us and the point that I just found, which is this one. So I'll call this x2, y2, how abouts. And let's see how well I do the distance formula. D is equal to the square root of y2 minus y1, -3, so minus and -3, all squared, plus x2 minus x1, minus a -9, all squared. And then I square root that whole thing. Distance formula is directly related to the Pythagorean theorem. -9 minus a -3 is -9 plus 3, ends up equaling -6, all squared. Don't drop those parentheses. If you do that, you'll be wrong, because squaring -6 in parentheses is different than squaring it without. One will be positive and one will be negative, yeah. So with parentheses, that's equal to positive 36. Without parentheses, it would equal -36. Yeah, square root of 72. Or I could write that as square root of 36 times the square root of 2, which is 6 rad 2 is the distance. Nope. It is approximately, because this is an irrational number, 8.4, 5, nope, 8.485, sorry. So there you go. That's all I'm going to do today. I might show one more problem for my in-class friends, but have a good day, internet friends.